So our last topic for columns is we're going to talk about design equations used for columns. So instead of using the graphs that we were shown on the last page, you can also do best fits, or you can use these types of equations to calculate for columns, to calculate the maximum loads allowable for columns. Right. So for different materials that have different equations. So for alloy steels, typically what we'll say is that there'll be either short columns, right, or there'll be long columns. All right, so short columns will follow a parabolic equation, and then the other columns would be a Euler equation. All right, so basically, if you have a short column, you use this equation on top. Long column, you use this equation on the bottom. Right. So basically, these are just your Euler equations and parabolic equations with some factors of safety that have been added in. So in the bottom, I'm just highlighting the factor of safeties for the both equations here. Right. Otherwise, they're basically the same parabolic and Euler equations that we defined earlier. Now for aluminum, using a column out of aluminum will act slightly different. So we have basically in aluminum, depending on the slenderness ratio, we'll have a short, intermediate, or a long column. All right. All right. And basically, the critical slenderness range is defined in these bracketed terms. Right. Here. Right. So otherwise, basically, it'll act exactly the same as we had earlier, right? So, and then everything in this, all these constants are in kpsi for these two sets of equations. All right, and that ends our discussion on columns.